guitars. They are arguably the nicest sounding instruments in a guitarist's perspective, of course. But I'm not gonna say that for nothing. You know, around 2.3 million guitars every day are sold in the United States, and in the world, there are an estimate of around 500 million guitarists sitting in their homes or in concerts playing this lovely instrument. The point is, guitars are very popular and they sound nice. But how can they produce this mystic sound we hear? Let's just cut to the chase. It's all about waves. We have Benson here with his legendary guitar playing. He will explain how he plays the different notes.
Whenever I move up the fretboard, I'm decreasing the wavelength. This is how you get different frequencies, also known as pitch on a guitar. In AP Physics, we learned about the relationship between the length of the guitar string and the length of the wave. The length of the wavelength produced is 2 times the guitar string length divided by the number of antinodes.
We can extend this concept further by combining it with the wave equation, which is frequency is equal to the wave speed over wavelength. Substitute wavelength for the equation Benson introduced, and we have frequency is equal to wavelength times the number of notes divided by 2 times the length of the string. We can look at this even further, multiplying both sides by 2 times the wavelength to show the relationship between the wavelength and frequency. They are inverses of each other, which makes total sense. The speed is always constant because the string's tension and the string's density is the same. We are not tuning the guitar while playing. We are not changing the material of the string, therefore speed is always constant. That means we can trust the sound the guitar makes if we put our finger on a certain position of the board. Because we know speed is constant, we can just move and change the length of the string however we want to adjust the frequency. So we can actually look at this in person. Well, kind of. If we film the guitar at a very, very high shutter speed and also turn up the ISO so we can actually see it's not too dark, we can actually see the strings moving side by side just as described earlier. It's quite a sight to see, and I'm actually going to put a capo, which is just a tool to help me press all the strings higher up the fretboard. You can see that the frequency is actually higher. You can hear the frequency getting higher, and also you can see the wavelength getting shorter. And that is really how guitars produce their sound. This video was created by Nathan Choi and Benson Zhao.